Alright, let's look at one more improper integral. Integral from negative infinity to infinity of x divided by x squared plus 1 dx. Okay, so again, we're going to split this into two integrals, and we're going to say this is equal to integral from negative infinity to 0. You can break it up at any point, really. We'll just choose 0 for convenience. Of x divided by x squared plus 1 dx plus the integral from 0 to infinity of the same function. We'll turn this into a limit problem again. The limit as b approaches negative infinity, and it becomes the integral from b 0 x divided by x squared plus 1 dx plus the limit as b goes to positive infinity of the integral from 0 to b, same function. Okay. So this integral should look a bit familiar. So it's just a basic U substitution. So we will we'll do this off to the side. U be the bottom, x squared plus 1 du equals 2x dx. So we get du over 2 equals x dx. The integral from x, the integral of x over x squared plus 1 dx becomes the integral of 1 over u times du over 2. Pull the 1/2 out. The integral of 1 over u du becomes 1/2 natural log of absolute value, and then you pull of u, and then we're going to plug back in and get 1/2 natural log absolute value. U was originally x squared plus 1, so we plug in x squared plus 1. This is our quick antiderivative. So we're going to skip some lines and go straight to here. Get the limit as b goes to negative infinity of 1/2 natural log of absolute value of x squared plus 1 evaluated from b to 0 plus the limit as b goes to infinity, same antiderivative, natural log of x squared plus 1 evaluated here from 0 to b. Plug in 1/2 natural log of 0 squared plus 1 minus natural log of b squared plus 1 plus 1/2, and then plug in over here as well, natural log of b squared plus 1 minus the natural log of 0 plus 1. Let's simplify this a bit. 1/2 Okay, natural log of 1, any logarithm of 1 is 0 minus logarithm, natural log of b squared plus 1 plus 1/2. I lost my limits here, so let me write those in. I ran out of room, so we'll write them real small. The limit b goes to negative infinity of this term, and then over here the limit of b goes to infinity of this expression. Natural log b squared plus 1 minus 0. Okay. So as b goes to negative infinity, this expression goes to negative infinity. And over here we have, well, I guess 1/2 times negative infinity, which is still negative infinity. And over here we have 1/2. As b goes to infinity, this one also goes to infinity. So that's a bit inconclusive. Okay. So we have negative infinity plus positive infinity. Again, remember that infinities are not real numbers as we know them. So because either parts of our problem goes to infinity, we're going to say the whole thing diverges. It is not the case that one infinity cancels out another infinity. Oh, that's our answer.